Internet, what is up? This is take two, you know? It's great when you record a video and it doesn't record and you come back and like, ah, gotta do it again, nice. So, this week, we read a book called Scale, and before we get into the book, I actually want to tell you about how I got to finding this book, because that's something I'm personally interested in when I research different books and I get recommendations from people. So the process of getting to this book was I actually listened to an interview on the portal with Eric Weinstein, and he interviewed an individual named Daniel Schmackenberger or something like that. I'll show a quick video of him here.
The Roman Empire, the Greek Empire, they all collapsed. And so the precedent is actually that civilization collapses, not that it maintains.
And after listening to the interview on the portal, I actually went off and listened to maybe 6 or 7 other interviews because I really liked the way this individual thought, what he said, and some of the controversial ideas he had. And in one of the interviews, he actually recommended a book called Scale. So the actual entire title of this book is quite long. I'll read it to you because why not? It's Scale. The subtitle is The Universal Laws of Growth, Innovation, Sustainability, and the Pace of Life in Organisms, Cities, Economies, and Companies. That is a mouthful. So I'm not going to recap and summarize the entire book because it's too much. If you're interested, you can go to the post as always and check it out, see what I've put in there. There's links and all kinds of good jazz. But what I'll do here is I'll touch on some of the ideas I thought were interesting, some of the things that jumped out to me, and also I'll give you kind of a quick synopsis of what it's about. So the synopsis and the summary and kind of the function and the purpose of the book is basically this individual is a physicist, and that's actually quite interesting to me because when you look at a physicist and how they approach a problem, they actually approach it usually from a first principles mindset. So they don't necessarily come with biases or different types of agendas from other branches of science, and they think about things at a fundamental level in comparison to maybe a biologist or a sociologist or something like that. And this individual actually approached a lot of these problems looking at it from like the building blocks of life and things like that. So let me get back to the purpose. So the purpose of the book is basically we're on a finite planet, right? So we only have so much supply to provide to ourselves, but we're actually on an infinite, not an infinite, but an exponential growth curve of consumption. So when you have an exponential growth curve of consumption and you only have a finite amount of resources, what happens when you reach the limit? Answer, there's usually a collapse at the end of that. So what this author does is he basically breaks down all these different ideas, and he asks a lot of big philosophical questions around why do we die and why do we live as long as we do, usually on average 100, a little bit below 100 years. And then he asks a whole bunch of other questions around cities and companies, etc. I have a few points here I'll point out which I thought were interesting. So the first one I want to talk about is actually a question that he asked near the beginning of the book was why do we die and why is the time limit set to what it is? And he actually broke it down all the way to the point where he came to the conclusion that it's entropy, because entropy is basically the end all and be all of everything. And entropy in a nutshell is a idea that comes from the second law of thermodynamics, which basically states that any energy that's created always has some sort of byproduct or waste. And that waste is usually not good for us. So and kind of basically how humans work with this whole concept of entropy is we have a metabolism, right? So we consume food and we take that food, we turn into energy. The energy usually goes through our blood cells, and the oxygen is then put to our cells, and it grows, reproduces, and maintains. And with this whole metabolism concept is over time, our internal infrastructure breaks down over time, our circulatory system, our veins, etc. It kind of deteriorates, and all that energy goes to waste. And that is usually reason why we die, is because we kind of, it's like an old car that breaks down, basically. And the interesting thing actually about the metabolism of living organisms in general, not just humans, is that certain animals are more efficient than others. So usually larger animals are more efficient than smaller animals. So if you look at a mouse and an elephant lives on average between like 60 and 70 years, and a mouse lives on average like 1 to 2 years. And there's a few reasons for that. One is the main one is actually the metabolic rate. So when a mouse eats food and consumes it and turns it into energy, it's super inefficient when the way that it actually spreads the energy amongst its cells, etc. But when you look at an elephant, it's actually, I think, 75% more efficient than a mouse, which is crazy. And this concept is actually it's actually the economies of scale. So if you look at a company, the reason a company that's larger is more efficient than a smaller one if they're in the same kind of industry is due to the fact that they usually have economies of scale and leverage on their competition. So they're able to create products in a more efficient and cost-efficient way. And you can actually take this concept, this fundamental principle, and apply it directly to living organisms like the mouse and elephant example. But in addition to that, you can actually apply that to cities. So if you look at cities, larger cities are actually more efficient than smaller cities in most aspects. So when it comes to their infrastructure, their distribution of utilities, and interestingly enough, they're actually carbon emissions. I didn't know this. And if you look at New York City and a smaller town, the per person carbon footprint for someone that lives in New York City compared to someone that lives in, I don't know, some tiny town elsewhere is actually drastically different, because a person here in the bigger city is actually more efficient due to the fact that there is public transportation and better infrastructure in place. And that's a surprise to me. So the next thing I want to mention here is actually open versus closed loop systems. So this is in the context of the way that we create energy, our energy resources. And this is, I guess, something I knew, but I didn't really, I guess, put it in this perspective. And when you think about our transition from where we are today to a completely carbon-free world, 100% decarbonized society, the traditional thought process is basically we'll take a basket of renewables, say hydro, solar, wind, etc., and then we'll take some nuclear fission, we'll put it together, and then we'll get to where we need to go. And that is the right approach. I mean, most likely it's the right approach because it's timely, we need to get there quickly. But the interesting question that was asked in this book and that I started thinking about is that, okay, once we get to that 100% decarbonized world, then what's next? And the what's next piece is basically saying that we're in a closed ecosystem. So a lot of what we're using is bounded to the planet. So the resources we're utilizing are here and only here. So to create an open loop system that can infinitely last, or not infinitely, but last a lot longer than a closed loop system can, is one that actually reaches outside of that system to another system, and that opens it up. And that reaching for us is going to be to the sun. And we need to basically figure out how we can capture, increase the efficiency of the capturing solar devices that we have today, and also the ability to store that energy in batteries and elsewhere, to basically have a infinite resource that can provide us as much energy as we need through mainly solar. Or the other option is basically taking the sun, bottling it up into a little package and putting it on the planet through nuclear fusion. And that's what a lot of people are working on today for many, many years. So that idea of actually having to expand the closed loop system to an open loop system so we can actually, last for a long, long, long time, hundreds and hundreds of years, is something interesting, and I didn't necessarily haven't thought about recently. And what I'll end you with here is basically the last point that he makes in the end of the book is the exponential curve that we're on for consumption. So if you look at an exponential curve, you can see that it's always up and to the right, right? And I'll show a graph here. But when it's up and to the right, there's always an end to this that no one ever talks about. And the end of it is usually a collapse. And you can see that in the graph that he shows. And what we've done historically to avoid this collapse is we've actually made technological changes over time throughout history. And some of these examples are when we've come across iron, we've come across steam engines, we've come across coal, computation, and most recently big data and machine learning. And we're making these shifts in technologies and these huge leaps in innovation. And this is basically what's happening with this exponential consumption curve is we're actually restarting the clock. And there's another graph he shows is where you can see all these exponential curves all attached to each other. And what's basically showing here is that instead of getting to the end point and collapsing, we're actually resetting the clock and starting over. Another analogy he gives here is basically imagine you're running on a treadmill, and this treadmill has an end point, and it's getting faster and faster and faster. And what you need to do if you don't want to run into the end point is you have to jump from your treadmill to the next treadmill. And that next treadmill you jump on is actually double the speed. So you're moving faster and faster, approaching another endpoint. So you have to jump off this treadmill onto another one, and that one's going double the speed. And you have to keep doing that over and over and over and over. And what's even more interesting is that actually as you go across, each of these innovation cycles are actually shortening down the time. So you only have so much time to actually come up with a new innovation. And this time is kind of collapsing over and over and over and over, getting shorter and shorter and shorter. Kind of final point he gets to around this is that he comes up with this grand unified theory of sustainability because he's a physicist, and that's what physicists like to do, is come up with grand unified theories. His theory is basically two things, right? So we have this technology innovation that we need to continue. It has to keep going. And we need to continue doing that so we can actually increase our supply and hopefully infinitely consume as much as we want and grow as much as we want. But in addition to that, is to actually fundamentally change the kind of collective consciousness of society. So it needs to be we need to have a more kind of system-wide approach to this problem, because right now we're focusing just on the tech and climate change, but this is all encompassed in a complex, adaptive, interconnected system. So there's healthcare, there's economics, there's governance, there's all these different parts that are a part of the system, all intertwined and touching each other. So he comes up with a conclusion of basically we need to focus not only on the tech because it needs to continue, but also we need to figure out a way to change the value system of humanity to, instead of focusing solely on being consumer-centric and growing and gaining more things and resources, etc., is focusing more on relationships and the more intangible things. And it's kind of fluffy and fluffy and like cliche, but it's transitioning that mindset and incentivizing people through behavior, saying, you know, that person values relationships over Lamborghini. That's great. We're not wasting so many resources, kind of thing. And this was a good book. This is a really good read. I mean, there was a lot of really interesting stuff in there that I didn't mention here that he talked about, like lifespan and the why companies die and all this crazy stuff. So if you're interested, you can go to the post to see more links, see more topics that I mentioned there. But that's about it, you know, internet. I'll see you next week, and we'll see what the book is.